Something that we've become pretty good at is finding derivatives. So for example, we know how to find the derivative of x squared. We know that that's just 2x. So we've spent a lot of time building our skills in that regard. But let's suppose that we're given 2x and we want to find what did you differentiate to get 2x. In other words, we want to find the antiderivative of 2x. See? In other words, we're wanting to go backwards. What did we differentiate to get 2x? Well, you can see here, we know it was x squared. But the way we would ask a question like this, the way we would write it, is we would use this integral symbol. And we would just put a 2x in here and then a dx here. So notice, it's a lot like the definite integral, except it doesn't have the limits. It doesn't have the limits of integration. So we say this is an indefinite integral. This is indefinite. And the answer to this problem right here is going to be x squared. See? Because the antiderivative of 2x is x squared. But it's not quite that simple, because think about it. If we say, what did you differentiate to get 2x? Well, x squared, that is the answer. But wouldn't this also be the answer? What if we said plus 5? Yeah. You could say, I differentiated x squared plus 5 to get 2x. Or I could say, this would also be true. I could say, I differentiated x squared minus pi. See, that derivative, because we've got constants, right? And the derivative of a constant is 0. So what we would do to cover all of our bases, to cover these constants, what we would do is we would say, okay, the derivative of 2x is going to be x squared plus c, where c is just some constant. And that way, that covers all of our bases. So here's the thing. We want to do some practice in finding antiderivatives. Now, as you can see, there's an infinite number of antiderivatives for this 2x. X squared plus c, that covers them all. All these antiderivatives, the only difference in them is going to be a constant. They're all going to be x squared and then some constant out there. So let's see about how we would go backwards. In other words, we're given the derivative, we want to get the antiderivative. So let's just suppose that we've got x to some value alpha. And we want to write the antiderivative. So we kind of did this with x squared up there. But now let's just suppose in general we've got x to the alpha. Well, when we differentiate, remember, we go down a power, right? So we started, if we've got alpha here, just like up here we had 2x, we've gone down a power, so we start with x squared. So this is going to be x to the alpha plus 1. So you remember, because differentiation diminishes the power. So let's see if this works. Let's see if this works. Let me differentiate this. I've got alpha plus 1, x to the alpha plus 1 minus 1. See, that's just the power rule for differentiation. And that gives us alpha plus 1, x to the alpha. Well, that's not this. See, we've got this extra alpha plus 1 there. So here's what we need to do. We need to say, okay, yeah, it's x to the alpha plus 1. Whoops. Yes, it's x to the alpha plus 1. Let me just... But we also divide by the alpha plus 1. See? So we have to remember to divide here. Now, if I differentiate this, let's see what happens. I get alpha plus 1, x to the alpha over alpha plus 1. And these cancel, and I get the x to the alpha. So that works for us. So that's the approach we want to take. So let's just see how this would work. Let's suppose we've got x to the third, and we want to differentiate that. Well, it's going to be 1 over 4, right? 3 plus 1, x to the 3 plus 1, and then plus a constant. Okay, so look, in general, we would say this. If we've got x to the alpha it's going to be 1 over alpha plus 1 x to the alpha plus 1. And you can, so it's going backwards. It's like the power rule, but it's for antiderivatives. So let's suppose we've got the square root of x. Well, remember, it's just like with differentiation. First of all, we write it with our fractional exponents. That having it in radical form like that doesn't do as much good. And then now we can say, okay, this is 1/2 plus 1. Now instead of 1, let me just write 2 halves. Go ahead and make it have the same denominator. X to the 1/2 plus 1 plus a constant. Okay. Well, now let's see what this is going to give us. This is going to give us 1 over 3 halves x to the 3 halves plus a constant. And then notice, I don't want to leave it like this, 1 over 3 halves. So let me just flip the bottom and call it 2/3 x to the 3 halves plus c. And that right there is our antiderivative. This represents all the antiderivatives for the square root of x. And this is the way we want to proceed with this. So this is the power rule for integration up here. And so this is the first, you can think of it as a rule that we can use for antiderivatives. Of course, a plus c there. Now remember also we've got our trig functions. So remember we could say, well, what about sine x? Well, the derivative of cosine is negative sine. So the antiderivative of sine would be negative cosine. See? The integral for cosine x, of course, that's just going to be sine x. And then we've got, let's see here, we've got secant squared x. That would be tangent x plus c. Yeah. And but in other words, there are these rules for the antiderivatives for the trig functions as well. And for those, it's just knowing them, right? So we could do another one. We could say, well, what about cosecant squared x? Let's just do sine, cosine, secant squared, and cosecant squared. Well, remember, the derivative of cotangent is negative cosecant. So this would be cotangent x, but we have a negative in front. Because this is positive here, the derivative of cotangent is a negative cosecant squared x. So what we're going to do is we're going to look at just various problems that involve these functions. So let's look here. Let's look at some. Let's suppose that we've got this situation here. Let's suppose that we've got 3x to the 4th plus 7x squared dx. Now, just like with differentiation, we can integrate across the plus or minus. So here we go. This is going to be 3 over 4 plus 1 x to the 4 plus 1. See? Just the power rule. Plus 7 over 2 plus 1 x to the 2 plus 1. And then plus c. And then we just simplify this. This is going to be 3/5 x to the 5th plus 7/3 x to the 3rd plus c. There we have it. So there's our antiderivative. Now, integration differs a little bit from differentiation because with integration there tends to not be a rule for everything. With differentiation, we've got a rule for everything, and you follow this rule correctly and you end up with the derivative. With integration, yeah, there are rules that we have that help us to solve some of the problems. But some integration, some antiderivatives require a little bit of creativity. So what we're looking at here is just the basics. And as we go along, we're going to develop our skills and do a lot more practice and see if we can figure out what some of these tricks are that we're going to be using later.